So today you're going to be learning how to find side lengths and angle measures of triangles. We are talking about old school right triangle trigonometry, okay? So remember with the right triangle, you have, of course, a 90-degree angle that indicates that it's the right triangle. Your two perpendicular sides are called legs. And of course, the side across from your 90-degree angle is always your hypotenuse. Now, when it comes to your right angle trigonometry, you always label your sides based off of one of your acute angles. Never your 90-degree angle. Never your 90-degree angle, always your acute angle. Okay? And that really and truly are what these two angles are. They're two acute angles. So if I use this angle down here that's labeled X, then this leg, the one that's opposite, or the one that's across from that angle, will be called your opposite side. Okay? And then the leg that's next to the angle would be called your adjacent side. Now, these two names are very important because together, opposite, adjacent, and hypotenuse tie into what old school concept?
SOHCAHTOA.
SOHCAHTOA. SOHCAHTOA was a way to remember all the different trigonometric ratios, sine, cosine, and tangent. Okay? So for sine, sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. And then TOA, tangent, opposite over adjacent. You do need to make sure that you include the angle beside each of the trig functions. That's what theta represents. So theta is your general symbol that's used to represent an angle. Okay. And all your three trig ratios are always attached to an angle. Now there are three others. Those are your inverse functions, but you don't have to worry about those in A and ASO. You just need to worry about these three. So SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Jeez, oh, scared me. And that's what we use to find angle measures and side lengths of triangles. Okay, so let's take a look at this very first example. We're going to find side A. As we see, we have a right triangle. So that's going to let us know that we're going to use SOHCAHTOA in some shape, way, or form.
Oh, you want us to say it?
Well, no, I was going to give you guys a second to write it.
Oh.
And it really is about a matter of labeling your sides and then identifying what is the best trig ratio for that. So remember, it's always based off of an acute angle that either you're given or you're trying to find. And now let's label. A would be what side?
Opposite.
Opposite. Remember, opposite means across, away from the acute angle. 6 would be our what?
Adjacent.
Adjacent side. Adjacent means next to. Not to be confused with the hypotenuse. The hypotenuse is always across from the 90-degree angle. So which trig ratio has adjacent and opposite together?
So tangent.
Tangent. So I'm using tangent theta equals opposite over adjacent. And I just need to plug everything in. Tangent, my angle is 34 degrees because I always use the acute angle. My opposite side is A, the variable I'm looking for. And my adjacent side is 6. How do I solve for A?
Multiply 6 to both sides.
Multiply 6 to both sides. So in my calculator, I'm going to do 6 times the tangent of 34 degrees to get my answer. So we will need our calculator for a good part of this unit.
3 significant figures?
Always.
Okay, I got 4.05.
4.05?
Oh, wait, oh, you're
So it's going to be 6, and then tangents located right above that parenthesis. And I just type in 34, and I click enter. Now, the one thing you do need to be careful about with the calculator is that the calculator can be in two different modes, degree and radian. So if you did not get 4.0 whatever, then that means you're probably in the wrong mode. So whenever you're doing a trigonometry problem and degrees are involved, you want to be in degree mode. So click on your mode button and make sure the fourth line down, degree is highlighted. If it's not, then you need to make sure it is highlighted. So let's say like it looked like this instead. Go over to degree, click enter. And then when you go back to try again to type that in, you'll end up with the correct answer. So three significant figures, A is what? 4.05.
05.
And of course, if there were units here, you would want to put the units. To find the size of angle B. So we can use SOHCAHTOA to find side lengths, but we can also use it to find angle measures. A new notation, this right here means angle, okay? So instead of it being written like this was old school geometry. Now it's written like this. And whatever letter is in the middle, that represents the vertex. That's the angle you're looking for, okay? So we're trying to find the size of angle B. B is one of your acute angles. So let's label our sides. 5 is our opposite, and 9 is our hypotenuse. Which trig ratio has opposite and hypotenuse in it?
Sine.
Sine. So sine of theta is equal to opposite over hypotenuse. And I filled everything in. My angle is what I'm looking for, so I'm going to replace that with the letter B. So sine of B equals O 5 over H 9. Now this is a tad bit different from when you're looking for a side length. When you're looking for an angle measure, you want to do the inverse of the trig function. Because you can't divide by sine, because sine is attached to an angle. To get rid of the sine, you do the inverse of that trig ratio. Performing the inverse is how you get rid of the sine that's attached to the B. So sine inverse of 5 over 9. So to get the inverse, you press the second button, then you press the respective trig ratio button. You can see all the different symbols that are above. We've got sine inverse, cosine inverse, tangent inverse, and then 5 divided by 9 to get your answer. You guys get 33.7? Mm-hmm. Perfect. And your answer should make sense. Remember, B and whatever this angle was up here, they're acute angles. Acute means they need to be what?
Smaller than 90.
Smaller than 90. So if you get a number that's like 125, I don't know what you typed in, but that's not correct. Okay.
So if it's negative, it's also not correct.
And if it's negative, let's say you got a negative value, you could potentially be in the wrong mode, because radian does sometimes produce a negative angle, so you want to make sure you're in the right mode.
Yes, ma'am.
Right. Along with some of your basic trigonometry stuff are your special right triangles. If you guys have been studying for the SAT, which I think you guys have been doing, you've seen this before. These are ways to find exact side lengths of special right triangles. 45, 45, 90, and 30, 60, 90. Give you guys a second to write that down. So how you can use this is basically saying that if you have a right triangle that has two congruent side lengths. First off, this is called an isosceles right triangle. And the legs, whatever the length of the legs are, the hypotenuse is always your leg times the square root of 2. Sometimes you could see this as an S, and then S root 2 to let you know that whatever the two legs are, you just multiply the hypotenuse by the square root of 2. So let's say this was 6, then you know this other leg is going to be, and then the hypotenuse is going to be
6 square root of 2.
6 square root of 2.
Um,
Okay, because all you do is you take whatever the leg length is and you attach a root 2 to it. Okay? You can go the other way as well. Let's say you were told that your hypotenuse was 9. Well, 9 corresponds to s square root of 2. So you could just set this equal to s square root of 2 and solve for s to get your legs. How would I solve for s?
Divide square root of 2 from both sides.
Very good. So you'll have 9 over the square root of 2. Can you have that? A square root in the denominator?
no,
How do I get rid of it?
multiply top and bottom by square.
So then that becomes 9 square root of 2 over
2.
what's square root of 2? So each of your legs will be 9 square root of 2 over 2. This will be the exact value of the legs. Okay? 30, 60, 90. Works the same way, but it's actually 3 different lengths. The side across from your 30 degrees is your shortest side. The side across from your 90-degree angle, your hypotenuse is twice the length of your shorter leg. And then the side across from your 60 is your shorter leg times the square root of 3. So you can also see this as x, and like that. Okay? So if you were given that this was 30 degrees down here, and this was 5, you know your hypotenuse is automatically
10.
twice the length of your shorter side. And then the side across from your 60 degrees, even though it's not labeled, it is 60. This will be 5 square root of 3. How many degrees are in a triangle?
How many what?
How many
One.
degrees are in a triangle?
180.
180. So even though it doesn't say that's 60 degrees, if you have a 90 and 30, 60 is what makes up the remaining 180 degrees. Okay. Another concept also that goes back with right triangle trig are angles of depression and elevation. These are more for your application type problems. Angles of elevation depression are created from a horizontal line. This is key. Always draw that horizontal line. Okay, bless you. And so let's say like here, I am looking out of that window, okay? But then I notice that there's a thumbtack above the door. So from where I'm looking, which is my horizontal, to me looking up at that thumbtack on the wall, that creates an angle of elevation. Me tilting my head up creates that angle of elevation. But again, that angle comes from a horizontal line going up. Same thing if I want to look at the trash can on the floor. I'm looking straight ahead out the window. I look down, and that creates my angle depression. It always comes from a horizontal line looking down. So let's take a look at an example, applying a few of these concepts, okay? A few of these concepts, right triangle trig, special right triangles, and angles of elevation and depression. This problem's really interesting because it says if A is equal to 2x, B is equal to 5x minus 1, and C is equal to x squared plus 1, x is an element of z, which are integers. Find the value of x, angles A and angle B. First off, angles are represented with capital letters. Side lengths are represented with lowercase letters. So let's clear that up to start. So when it says A is equal to 2x, we're talking about the side length is 2x. The side length is 5x minus 1. The side length is x squared plus 1. In order for me to find the value of x, what concept am I going to need to use to solve for x? Old school.
Is it Pythagorean theorem?
Pythagorean theorem.
Oh, man.
Yep, Pythagorean theorem. Which was what? What was Pythagorean theorem?
A squared plus B squared equals C squared.
You use Pythagorean theorem only for right triangles. when you know two sides and you're looking for a third, or in this case, I know all three sides, but I don't like actually know what they are. I just know that they should, a squared plus b squared should equal c squared. So I plug in, that's 2x that needs to be squared plus b that needs to be squared is equal to c that needs to be squared. C is always your hypotenuse, always. So even if the side lengths were labeled A, B, and C, the C in Pythagorean theorem is always the hypotenuse. What's 2x squared? Good. What am I gonna have to do with 5x minus 1?
FOIL.
FOIL. 5x times 5x.
25x squared.
This becomes minus 5x minus 5x. Negative 1 times negative 1.
Positive 1.
Good. So this becomes 25x squared minus 10x plus 1 is equal to, what do I have to do to that last part?
FOIL.
X squared plus x squared is x.
To the 4th power.
Very good. This gives me x squared, another x squared, and a positive 1. So this becomes x to the 4th
Plus 2x squared.
plus 1. Now, in order to solve this, because I believe this, let's get everything onto one side, okay? Oh, no, it's not gonna be, okay, because we have that term. All right. So yeah, let's get everything to one side. Let's set it equal to 0. So let's subtract the 4x, well, technically 4x squared and 25x squared make,
29x squared.
so let's subtract the 29x squared from both sides. Let's subtract 1 from both sides. And we're gonna add a 10x over. So this becomes x to the 4th minus 27x squared plus 10x.
Oh, 27.
Hmm?
Yeah, no, I got confused, but not anymore.
All right, now in order for us to solve this, I mean, we could take out an x, but that's really not gonna help us any. So we're gonna need to use our calculator. We're gonna have to graph and find their intersection points.
Wait, how do we get to 29?
Did you graph this?
Uh-huh. You said, how do we get 29? Because 4x squared plus 25x squared made a 29x squared.
Oh, okay.
And so then I just subtracted 29x squared over to get rid of those two terms. So in our graphing calculator, we're gonna put 0 into y1 and then the other side into y2. We did this sum when we were doing sequences and series and looking for particular values and things like that. Essentially, we want to see where 0 and that function intersect each other, right? So let's graph. Okay, we got a few places here, right? Now, but the thing is, we're told that x has to be a what? From the problem, it said that x had to be a what?
Integer.
Integer. And you can kind of look, I don't know how well you can see on my graph, but maybe on yours, you can see that at this point, that's gonna be a decimal. That one right there, that one's gonna be a 0. And I can't have 0 for a side length. This one's another decimal, so it looks like my only option is gonna be that one over there.
I didn't get the middle part.
It's probably because you might be very zoomed out. So maybe that's why. Like mine's on a standard window. Press zoom 6.
Wait, what?
Zoom is the third button in the middle, top middle,
Oh, zoom,
and then number 6.
Okay.
zoom 6. Okay.
There you go. All right, so we want to find that intersection point. So we go to second trace. Second trace, we want to go to option 5.
It still doesn't show up.
Now, we want to get that intersection point over here on the far, far right. My cursor is blinking at 0, 0. I have to move my cursor closer to that intersection point. Otherwise, it's going to give me a different one. So once it's closer to that intersection point, I'm going to click enter 3 times. 1, 2, 3. I don't move it in between or anything like that. So x is equal to 5.
5.
So now that I know that x is equal to 5, I can find my side lengths and I can find my angles. Okay. So if x is equal to 5, side A is 10, side B is 24, and side C is 26. So to find angle A, for example, I can use any one of the trig ratios because I have all 3 sides. Okay? So choose which trig ratio you want to use, set it up correctly, and find angle A. Which trig ratio do you guys use to find angle A?
Same.
Sorry.
Sine.
So sine of angle A, what were your 2 sides if you use sine?
Opposite and hypotenuse.
So what numbers?
10 and 26.
Very good. And since I'm looking for an angle, I need to do the,
Negative sign.
which is the inverse. Now you don't have to worry about reducing this fraction because you're, whether it's reduced or not reduced, you're still taking the inverse of it. So when you go into your calculator, second sine, 10 divided by 26, 22.6. Very good.
I use 10.
And you use tangent,
Yeah.
and you still got 22.6. Exactly. No matter which trig ratio you use, as long as you have the correct ratio, you'll get the correct angle. And since we know that there's 180 degrees in a triangle, we don't have to go through the sine, cosine, tangent feature to find angle B. We could just add up the angles we have and subtract it from 180. Now, if you did, that's okay, because we should still get the same answer. So 180 minus the 90-degree angle minus the 22.6 degree angle, but I'm not using the rounded answer, I'm using the full answer. Did you get 67.3 or 0.4?
Yes.
Yes.
Very good. So angle B, 67.4 degrees. Anytime you decide to use a previous answer to answer something else, always use the non-rounded answer.
But wouldn't it not make a difference for like something like this? Because
You know, it has to be 108. Yeah. Yeah, in this case, it wouldn't make a difference, but when we start dealing with non-right triangles, then it's going to make a difference, just a minor difference. So. Let's look at this one. We're going to find the exact values of x, y, and z. And then we'll have one more problem, and then we'll be done for the day.
$9 million.
All right. We are finding the exact values. Okay, so exact means no decimal approximation, no calculator. It's all our knowledge. And if you look, these are actually special right triangles. Okay, PQR is a which triangle? It's isosceles and it's a right one. So if I have 8 and 8 here, then this one has to be what?
8 square root.
Very good. So that means that x is equal to 8 square root of 2, because it's one of our special right triangles. Now let's look at the other triangle, PQS, where this is Z, this is 90, I know this is 8, and this is 30, and then QS, how can I represent QS?
You mean like a variable or like 8 plus 1?
8 plus 1.
Plus y. Spot on. Okay, so 8 plus y. Now, if you recall from special right triangles, since I know the side across from my 30-degree angle to be 8, then I easily know my hypotenuse. What's gonna be my hypotenuse?
Oh, 8. Is it?
16.
It's 16.
Oh,
Because remember, the setup is, this is x, this is x root 3, and then this is 2x. So it's twice the length of the shorter leg.
Oh,
So if that's 8, then the hypotenuse is double, so 16. All right, now to find this side though, okay? This side is opposite of the 60, okay? So according to this side should equal what?
8 square root 3.
Exactly, because it's the shorter leg times the square root of 3. So to find y, I have an equation here. 8 plus y is equal to 8 square root of 3. So y is going to equal,
8 square root of 3 minus 8.
and that's the exact values of x, y, and z.
oh,
So exact means no decimal approximations, okay? Simplified radicals, simplified fractions, and that is the most exact length possible for QS.
it doesn't need to be decimal and all that.
Correct. Anytime it says exact, is no decimal approximation. All right, last one we're going to do for the day. It is a word problem. An observer stands 100 meters from the base of a building. The angle of elevation to the top of the building is 65 degrees. How tall is the building to the nearest meter? A picture would be good here, right? Yeah,
Yeah.
definitely. Picture would definitely be good here. An observer stands 100 meters from the base of a building. So I probably need an observer and a building, right? And both the observer and the building are on the same ground, right? All right. Now it says the angle of elevation to the top of the building is 65 degrees. Now, it didn't say from the person's eye or anything like that, so we can make the assumption that it's coming from the ground level. And it says angle of elevation. Remember that, how much I was harping on the fact from a horizontal line looking up. That horizontal line is going to be the ground. There's your horizontal. So looking up to the top of the building, that angle is 65 degrees. Now, the building and the ground make a what angle?
Right.
So this is a right triangle. How far is the observer away from the building?
100 meters.
So to find the height of the building to the nearest meter, I'm looking for this. What trig function am I using? Very good. So it's gonna be tangent of my angle, which is equals my
X,
over
100,
opposite over adjacent. So for an x, I'm going to
100 both sides,
multiply 100 to both sides. So 100 tangent 65. You'll see me do this a lot, especially in this unit. I will always write whatever it is you're supposed to type into your calculator. So if you end up, for whatever reason, not having a calculator or not getting the same thing, go back and make sure that you've typed in exactly what you see on the board. So to the nearest meter, how tall?
214 meters.
214.
Yeah, that's what it is.
Confirmation?
Yes.
Wonderful. Okay. Now, a few things I just want to point out because I've noticed it in the problems that I chose is that all the ones where we were looking for side lengths, the variable is on the top. Okay. So let's say it was backwards, right? Let's say that we wanted to find same situation. Let's say the person was 100 meters away, but we wanted to figure out how far from the top of the building the person was. Okay, so that means we're looking for this. What trig ratio am I going to use here?
Wait, no. Sine, is it sine?
Cosine.
It'll be cosine because x is my hypotenuse, but 100 is my adjacent. It's next to that angle. So this will be cosine 65 equals my adjacent side over my hypotenuse. Now this is different when the variable's in the denominator. Okay, it's different when the variable's in the denominator. So I wanted to make sure to highlight this so if you happen to get one like this, you will be confused. How would I solve for x?
multiply x off of both sides.
Exactly. If I multiply x to both sides, that gets rid of the x in the denominator on the right-hand side.
And then you divide by cosine 65.
Exactly. So when your variable's in the denominator, you divide instead of multiply. And a lot of students, they automatically think that, oh, I'm just going to multiply. No. There is a time when you have to divide your side length by your trig ratio. And so then you will get our answer. 236?
237.
I'm 37, sorry.
Okay, 237. Watch those three significant figures. But that's how we would do it if the variable's in the denominator. Okay? Let's change it up one more time. Let's say the person was not at the bottom of the building. Let's say they were at the top of the building. Okay, now they're up here. And they spot a car. Okay? They spot a car that's 100 meters away. Okay? Then it said the angle of depression was 60 degrees. If the person's standing at the top of the building, remember, angles of elevation depression always come from a horizontal line looking down. That angle that's created between that horizontal line and you actually looking down to the vehicle is your angle of depression. Okay, a lot of students like to draw your angles of depression from that vertical line, that building or that cliff. It always comes from a horizontal line looking down. Yes.
Is it 65 or 60?
Oh, 60, I'm sorry. I was thinking about the first problem. Okay, so always from a horizontal line looking down, that is your angle of depression. Never between the vertical line and the line you're looking at. Okay, but here's your right triangle. The only angle I know is this 90-degree angle right here, or at least right now. Horizontal lines are always what?
Adjacent?
Not adjacent,
Not adjacent.
parallel. Parallel lines create these two congruent angles. Alternate, interior congruent angles. Throwback from geometry. So if you have an angle of depression that's outside of the triangle you need, its alternate interior angle will also be that angle every time. So then you'll be able to solve whatever you need to.
I think we need to have a review on this whole alternate interior stuff one day.
Oh, for SAT?
Or just in general, because I know there's vertical corresponding alternate, and some wasn't there a thing like a hypotenuse leg, but I don't even know what they mean anymore.
Oh yeah, but that was with proving triangles congruent. You won't have to worry about nothing like that in that class or the SAT. They don't do any of those.
No, they actually have that on the SAT apparently.
I haven't seen one in my dealings, but I haven't lived in geometry in a long time. But we can definitely go over those. But this concept for sure, you'll definitely need with right triangles. So just make sure you always label your sides. SOHCAHTOA is based off of an acute angle, and then your special right triangles.